Solving systems of equations. Now, we already had an opportunity to do that up here. We had the equal values method, and so we might look at possibly utilizing that, but the way these both are set up are the other two ways that we've done this in the past. This would be a combination approach or elimination, where if we combine these two together, or these two equations, they're lined up so that the x's are the same, they're together, the y's are together, and the constant on the other side is together. The problem with the original setup is that nothing's going to eliminate. This only works if we combine them so that something eliminates. And if you look, 2x and 3x both go into 6, so we can alter both equations. But if you look at these, this is a -1. Okay, that's a 3y. We can turn this in to a -3y. And that would allow us then to combine these together, and the 3y minus 3y would cancel out. So what we can do is take this equation and adjust the entire equation for the sole purpose of turning that into a -3y so that the y's will cancel. Okay, so we're going to put a 3 out in front. We're going to distribute it to everything. That gives us a 9x minus 3y, which was our goal. And this equals 15. Don't forget to multiply that by the other side of the equation too. We didn't have to change the sign because it was already negative. And I like to, just to make sure we got everything kind of lined up here, I'm just going to move that equation down underneath here so that we can kind of see what we're working with. So that 2x is, I've just moved it here. This is a plus 3y, so we can see that we've accomplished our goal here. And a 7 right down underneath. All we did is we transferred that equation down here so that I can see what I'm adding together. Here I see that I have an 11x. And as I hoped and was trying to do, these are going to cancel. Something must cancel, otherwise you're not going to be able to solve this. 15 and 7 is 22, conveniently enough, because if I divide by 11, I'm going to get x equals 2. All right. Now right away I can plop that up in there, and that's good, and we want to make sure that we understand that, but that should hopefully remind you that, hey, wait, we're not done yet. Okay, now this equation has a negative, and we also have multiplied it by 3. It doesn't matter which one, it'll work for both, but you need to go back to one of the equations now and plug 2 in for x. I think we'll take that top one. So we have a 2 times something plus 3y equals 7. I like to write it out that way and point out that that equation and that equation are the same. Okay, they are the same equation. You know, you say, well, y is an unknown, x is an unknown, so is an open set of parentheses. The point of changing it so that the x is gone and I've got a set of parentheses is we know what x is. We don't have to stay with an unknown x. We can now put a known quantity in for x, and we know that that's equal to 2. If I know x is equal to 2, let's put it in and then see what y is. So 2 times 2 is 4. I got a 4 plus 3y is equal to 7. Let's subtract 4 from both sides because that'll go away now. Now I got a 3y is equal to 3. Aha. Divide by 3, and now you get y equals 1. So the cool thing about that is we plugged x into here. If I plugged 2 into this one, we'll just kind of do it quick here. That would give me a 6. 3 times 2 is 6. 6 minus y equals 5. So if I subtract the 6 from both sides, I'd have a negative y equals -1, which would in turn make that the same. Now over here, like I did up here, I'm going to give you the opportunity to solve this. There's a couple different ways you can approach it. You're really close to the equal values method, but since this is here, we can't. So one thing you could do is you can move the 3x over to the other side and then have equal values method and set them equal. Or because you have this thing right here that shows that you have y equals something, you can use the substitution approach. Here's another y in the second equation. So since I know y is equal to that, what if I did this? Okay, I rewrote this equation, and instead of a y, I put a set of parentheses, kind of like I did with the 2 over here. Now I can put something else in the parentheses that I know is equal to y. That's what that equation up there is all about. Y equals x plus 3. So let's put x plus 3 in place of y. This second equation is that equation right there, but in place of y, I put what we're told y is equal to. Okay, the point of that then is so that we can now combine our like terms. Yes, there's parentheses, but that doesn't mean multiply, because you have x plus 3 minus 3x. The parentheses are there to show that we put this in place of the y that's here. Okay, so now all we have is we have an x and we have a -3x. If we combine them together, we have a -2x. So I have a 3 minus 2x is equal to 13. Remember, that is a 1, and 1 minus 3 is negative 2. 1x minus 3x is negative 2. Now, we'll keep that negative 2 there because this 3 matches that. If I take 3 away from both sides, then I have a negative 2x, don't forget that negative still applies, is equal to 10. All right. Now we're down to it, not a lot of space, but if I divide both sides by negative 2, and negative 2, those negative 2's are going to cancel. 10 divided by negative 2, I get x equals negative 5. It's important we keep track of that negative. Oh wait, I was going to let you do this. Tell you what, plug that back in here, find out what the y value is.